talking about soil health, malic is probably not your best extractant to use when you're trying to evaluate what the microbes are seeing, what they're living in, what the plants grow in from a soil solution standpoint. From a chemistry standpoint, it might make perfect sense. Like if you're just talking about benchtop chemistry, that's fine. But that's where we're kind of working with the transition of people trying to say, okay, chemistry is important, but chemistry is influenced by biology. If chemistry was the answer, it would be really simple, right? We would all be growing the 300 plus bushel corn every year because it would be easy. 1 + 1 = 2. If you measure what you got out there and we say corn needs this much, it's simple mathematics. Take this minus this and put on the rest, and there you go. You get it all out. Well, that's not how it works, obviously. We all know that. So,
but I know you focus, especially with your testing, your specialized testing, you focus on the water solution that's available in the soil, where no other. You don't hear that from other labs. They just want to run soil tests. Here's your results, and farmers are beginning. I think we're on the front end of them beginning to understand there's a whole lot more going on in the soil than I think, because I've been testing for years, and I go to the co-op, and the co-op says, well, based on that, you need more NPK, and now it's like I'm not getting results with more NPK. So what is wrong? And I think that's where your lab is really specializing.
Yeah, we try to focus on, and I've shared this in my talks, and you know, for those of you that might see this and hear it, I'm sure you're tired of hearing about it, but I look at the soil like a distribution chain. So when you think about, you know, most farmers see themselves as the supplier of raw material. Well, before that farmer is a supplier of raw material, there's an entire distribution chain that takes place in your farming operation. So we have the supplier of raw material. The supplier of raw material is Mother Nature and God. It's not, honestly, the product companies. It's not the fertilizer companies. I mean, we are fertilizing with naturally occurring elements. Phosphorus, I don't care whether, you know, I know they always use the term synthetic. There's no such thing as synthetic phosphorus. It's a naturally occurring element, right? How we package it and deliver it, that's a little different. Now, we get into herbicides and pesticides, that is certainly where synthetic can be thrown in, but nutrients, they're all naturally occurring. So the supplier is Mother Nature and God. Soil is the warehouse. The microbes are the distribution chain. They are the forklift operators, the dock unloaders, the truck drivers, etc. Now, in order for them to do their job, they have to have the right tools. Number one, yes, there has to be stuff stocked in the warehouse. But number two, they need the soil, the structure. They have to have the structure. Just like if I want to ship something from Amazon, how does Amazon get it to me? Well, it's got to be in their warehouse, and they have to have people there to load it onto a truck, somebody to drive the truck, and they got to have some way to get the truck here. The infrastructure, the interstates, the highway systems, railways, airlines, etc. That is structure in the soil. Porosity, aggregates, all of those things. The fuel that moves them is water. Water is the conduit that moves them. And then we've got carbon for energy, and think of it like paying those employees. That's what they're being paid, is carbon. Who is the retailer in this, or the manufacturer in this instance? That's your crop. Your crop is taking these raw materials delivered through the distribution chain to build something. So they are manufacturing something. Corn seeds, soybean seeds, leaves, stalks, roots. The farmer is a retailer. They're the consumer in taking this, and now they're the retailer. They're going to sell it into a different supply chain. In ag, we have focused heavily on the output of the retailer, yield, and what's in the warehouse. And I call it the moron approach. I'm not calling people morons, I'm just saying it's the moron approach. If you're not happy with the output of the factory, the answer has always been put more in the warehouse. put more on. Well, that model works great, and yes, it has increased in a lot of cases the output of the factory, but with what cost to efficiency, right? So there's a ROI, and if we're putting all this on, and 35, 40 years ago, putting on extra was cheap insurance. But the cost of these goods and the cost of getting them here and the cost of getting them applied is not linear with the increase in return on your commodities. Yeah. Especially as we continue to move yields up, now we're under constraints that are well beyond what's in the warehouse and even how much you can transport. Now you're under constraints of moisture, growing season, growing degree days, disease, and all these other things that influence yield, right? So Barry Fisher, been involved with NRCS soil health for a long time. He said to me one time at a talk, I heard him say, he goes, our best guess is that 70 to 80% of your yield potential is completely out of your control. So the way you get these out is to stop putting so much on. And it forces the plants, the retailer knows that the cost of doing business exists. That's why a corn crop pumps 50% of its carbon into the soil through the roots. It's not because it's leaky or because it's lazy. It's because it has to pay those organisms carbon in order to move potassium and move phosphorus. When they do that, the plants are bigger, stronger, healthier, and guess what? They capture more carbon. And the more carbon they capture, the more they can feed the organisms. They're like, well, if I'm not getting paid or if I'm not getting supported, then forget you and I leave. And it doesn't matter, and the whole thing falls apart. I know it sounds really kind of pie in the sky, but if you really think about what those individual processes are, how many people say I've got calcium problems? They're evaluating the clipboard, right? Plant sap analysis or plant tissue analysis. What you're really doing is you're looking to see what got delivered to the factory. You're going, yep, I got nitrogen, I got calcium. Where's the phosphorus? Well, I don't know. Did it get on the truck? Well, I don't know. Let's go check the warehouse. And they look at the warehouse and go, well, we've got it here. We just need more of it. Well, no, you're missing something here. Mm-hmm. Those organisms aren't there that want to do that. If you fix that channel and open that up, you get to a point where fertilizer is used to supplement your removal rather than force into the plant. Mm-hmm. And that's really what we're trying to work with growers, is to give. I always get the question, so it's all or nothing. They're like, oh, so you're a soil health guy, so you're against fertilizer, you're against herbicides. It's like, no, I'm not against any of those things. I'm not. I want to give the buying power back to the grower. I mean, just naturally, by planting cereal rye ahead of soybeans, you're very likely going to reduce your herbicide use by 30 to 50%. And it's not because of a soil health benefit, it's just because you're going to see less weed pressure if you really have a nice rye stand in soybeans. Mm. You just, so the need for you to use it is not as much. So yeah, again, with a lot of these tests, the way we approach this is kind of more like a medical analogy, where we're trying to run a suite of things that are indicators of how well your system functions. Mm-hmm. Blood pressure, cholesterol, height, weight, etc. We identify areas that are working well and identify areas that maybe need improvement. Okay? And then those areas that need improvement are more general guidelines. And so our recommendations outside of fertility, it's not like, hey, you need to go buy 200 head of cows and put them on your farm. No, it's, hey, your WEOC number is low. Well, you're in a corn bean rotation and without coverage. Beans are a carbon negative crop. So if we want to get this number up, we either need to change the rotation slightly, add a third carbon crop in there, wheat, for example, or milo, or integrate some higher carbon cover crops like rye after corn ahead of beans, right? And so working through those steps, and then we use the test to come back a certain time later and evaluate whether or not there were improvements. Just like getting blood work done or a physical done. Help you with that.
Yeah, I really like your analogy a while ago about the warehouse, that so many farmers have filled the warehouse for years and years and years. And then you talk about the retail, okay, they keep changing varieties or they change a different crop or whatever on this end, but they do nothing to feed or pay the workers that goes between the warehouse and the retail crop at the end. And this is exactly where they need to focus. They don't need to keep focusing on the warehouse or even the retail of the crop, and then they don't get the results they want. Well, it's because they never fed or paid the workers going between it. And I love that. That's pretty neat.
They want carbon. If you haven't seen it, look up the Carbonomics talk from Keith Burns at Green Cover Seed. It's a wonderful talk. It's on YouTube. Talks a lot about the carbon as a form of payment through the system. They really want a house to live in, and they want food to eat.
Yeah.
That's what the microbes want. And we do a lot to destroy their house, a lot, and limit the amount of food they can eat. Keep in mind that actually before we farm plants, microbes farm plants. So, and plants farm microbes. You know, it's what we call a positive feedback loop in biology. Or in other words, you scratch my back, I'll scratch yours. That is the way soils have been built. It is the combination of parent material with mineralogy and that type of thing, coupled with carbon brought in by plants, and the transfer of the two built together with microorganisms. And that's where soils come from. And we kind of forget that, and we think, oh, it's here, let's abuse the hell out of it, right? And get it to produce all the food we need. I had a hard reality, this is an ego reality, you know, when I was 25, you know, 25 and puff your chest out and nothing can stop you, but microbes actually run this entire planet. We just live here.
That's true.
You are more microbe than you are human. Soils, I mean, the stuff we don't even know about. Sometimes we as people want to manage it all. And sometimes the best thing you can do is kind of provide the building blocks to your 4-year-old son and then step out of the way. Don't tell him how they need to be organized and what he should build. Just step out of the way and you'll be amazed at what they create. And
True.
So our job is to provide those building blocks, make sure that the nutrients are there, make sure that we're getting carbon into the system, put plants and diversity of plants into the system, and watch what comes out.
And that's key because he's building his context.
That's right. Yep. Building his context. That's right. So